Okay, so our very last video talks about what is the difference, in terms of these two functions. Like instead of it just as a property, now it's a function. How does that impact what we're looking at? Because I could tell by my property that if I have an exponent up here of a 2, that could come down in front and put a 2 there. But when you have a function that's using those properties, you have to be cautious because simplifying in terms of just a property sometimes affects the domain of your function. If you have x squared before you take the log, that means even when x is negative, so all of this space over here technically is being squared before the log is applied. Therefore, it could have, and it does have, valid outputs. Where here, I'm taking my x and only positives can get into log, and then I multiply by 2. So the domain is going to be different. The graphs will look different. If I start here, it doesn't really matter. I guess I can start here. So log base 2 of 2, like log base 2 of x. So if I put in 1, that's still going to give me my intercept of 0. Okay. But now if I put in 2, log base 2 of 2 is 1. 1 times 2 is 2. So I go 2, 2. If I put in 4, that's another nice value. Log base 2 of 4 is 2. Double it. So that's 2 times 2 is 4. 4, 1, 2, 3. So it's starting to look linear at first, but it's not. Because when I put in 8, log base 2 of 8 would be 3. 3 times 2 is 6. So if I could count out to 8, 1, 2, 3, 4, 5, 6, 7, 8, it'd go up to 6. Okay? And so then here's my graph. Maybe I'll choose, I guess, green. I don't know. Green shows up. So it's our characteristic log shape. It's just that it becomes with a vertical stretch because of that 2. There's still an asymptote at x equals 0. Right, so x equals 0, and I've labeled key points, or at least I've plotted key points for my graph, so I get full credit. Now, log base 2 of x squared is that graph plus its negative image. So all the values that worked on the positives here will work here. Because think of it, you're putting in 1, 1 squared is still 1, so the output is 0. Put in 2, 2 squared is 4, log base 2 of 4 is 2. You put in 4, so 4 squared is 16, log base 2 of 16 is 4. So same output. You put in 8, 8 squared is 64, log base 2 of 64 gives you 6, 2, 4, 8, 16, 32, 64. So I get the same first part of the graph. So here's our log curve. Okay, and I still have my vertical asymptote at x equals 0. Okay, so there's there. But then because I'm squaring it before I log, then that means that 1 and negative 1 are going to behave the same because they're both outputs as 1. Negative 2 and positive 2 are going to behave the same. Negative 4 and positive 4 are going to behave the same. Negative 6 and negative 8 and positive 8 are going to behave the same. So I get a reflection, a mirror image of this particular function. Still, I can't have x equals 0 because I still can't take the log of 0, but notice the domain is now both positives and negatives. And so my point is, or my caution is that if you're analyzing a function, right? So my caution is if you're analyzing a function and you've used a log property to simplify, that means that you, so the question is which one is the right one? It has to go back to what was originally given. If this was originally given, then this is the graph you need. If you accidentally simplified or thought you were doing something good and simplified and got this graph, this is technically wrong. This is not the graph of the original function. So when it comes down to graphs and specifically domains, you have to use what was originally given. So the graph slash function slash domain, I guess depending on what is it that they're actually asking. So the graph or the function or the domain must match the original problem. And you can bet that I'm going to test you on that, assess you on that, because finding domain has been a huge part of this early, of this early part of the semester. So don't simplify a function if you're analyzing it using a log property. If it's just a problem you're evaluating, yeah, simplify it like the first couple of examples that we did in the first 2 videos. Graph or the function or the domain must match the original problem. Okay, so, and again, I'm hoping a lot of this seemed familiar. You went through all 3 videos. I appreciate that. And just kind of it's good reference to check, come in for questions. But those are the things that you should expect from this section of our log chapter.